In this video, we are going to discuss projections of a hexagonal prism with the condition base inclined to HP and axis parallel to VP. Let us discuss a problem. A hexagonal prism with the side of the hexagon 20 mm and height 50 mm is resting on the HP on one of its base edges in such a way that the base is inclined at 30 degree to the HP. Draw its projections. In this problem, the base is 30 degrees inclined to HP. When the base of a solid is theta degree inclined, the axis also will be inclined with an angle 90 minus theta degrees. So in this case, the axis will be 60 degrees inclined to HP. Further, the prism is resting with its base edge on HP, so that the resting base edge will be perpendicular to VP and axis will be parallel to VP. For this condition, axis inclined to HP and parallel to VP, all the possibilities of all the solids are explained in a previous video. Whenever the axis of a solid is inclined to HP, the projections of the solids can be drawn only in two stages. In the first stage, the axis will be assumed as perpendicular to HP, so that the base shape of the prism can be properly seen in the plan. In that case also, the axis will be parallel to VP. While drawing the plan, the resting base edge should be made perpendicular to VP. So after drawing the XY line, draw a hexagon as the plan of the prism, draw a vertical line, draw a circle with the side of the hexagon as radius, that is 20 mm. From the end points of the center line, cut arcs on both the sides of the circle. Join these points to complete the hexagon. Bottom base corners are named as 1, 2, 3, 4, 5 and 6. The top base corners are A, B, C, D, E and F. Here the center need not be found out because in the front view both the longer edges and the axis will overlap. So project the corner 3 and draw it as an axis in the elevation. Maintain the height 50 mm of prism in the elevation. Project all the base corners also. Longer edges 2B, 3C and 4D are visible. The other three longer edges will overlap with these, so we need not bother about that. The top and bottom bases can be seen as horizontal lines. Name the bottom base corners as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Top base corners as A dash, B dash, C dash, D dash, E dash and F dash. This is the projections of a hexagonal prism with the condition axis perpendicular to HP and parallel to VP, the first stage of projection. And also the entire base is on the HP with two of its base edges perpendicular to VP. For polygons having an even number of sides, when one edge is kept perpendicular or parallel to one of the planes, the opposite edge also will have the same condition to the same plane. The question says that the base is inclined at 30 degrees to HP. Since the base and axis are mutually perpendicular, when the base is inclined, the axis also will be inclined. Draw a 30-degree inclined line. This is the base of the prism. Measure its length from the first stage elevation and mark it on this inclined line. With respect to this base, reconstruct the second stage elevation as a tilted first stage elevation. Since the base is 30 degrees inclined, we can see that axis is 90 minus 30, that is 60 degrees inclined. Mark the corresponding points of base corners. To draw the final plan or second plan, project all these points below the XY line. Project all the base corners from the first stage plan also. Trace the corresponding points of intersection. While looking from the top base of the hexagonal prism is fully visible. So all the base edges AB, BC, CD, DE, EF and FA are dark. Only the outer portion of the bottom base is visible. Base edges 6, 1, 1, 2 and 2, 3 are dark. The other three base edges 3, 4, 4, 5 and 5, 6 are invisible. Hence should be drawn as hidden lines. The longer edges 6F, 1A, 2B and 3C are visible dark edges. The other two longer edges 4D and 5E are invisible. By this, the projection of the hexagonal prism resting on the ground with its base edge with the base inclined to HP and axis parallel to VP are drawn.